So the screen is visible as well. Can someone respond?
Yes, sir. Visible, sir.
Your audio is not clear to me. Can someone speak? Hello?
Sir,
No, sir,
it's
it's
visible.
audible.
Yes, sir.
Okay.
It's visible.
Yeah. No, your audio was not coming to me. Is there an echo from my side when you guys speak?
No, sir.
Okay, things are clear, right?
Yes, sir.
Okay. Just trying to set few things here. Slow. Okay. So sorry, I just yeah. Okay, so I think we discussed air cooling and then the merits and demerits of air cooling, right? I think that's what we discussed till yesterday. Am I correct? Can someone just confirm?
Yes, sir.
Yeah.
Yes, sir.
No, my speaker has some issues. All right, but I'm sure you guys are able to hear me, so I'm just going to continue. So next is liquid cooling. Yeah. So what's the most widely used coolant? Most widely used coolant is water, but then liquid cooling is most commonly used in engine cooling systems. The reason is it has better heat transfer. Obviously, yesterday someone said that liquid has better heat transfer coefficient compared to air. I mean, when you take a combination of a certain surface and liquid, so the heat transfer coefficient is much higher compared to just surface to air, right? And the commonly used coolants are water. Even today, water is the most commonly used coolant with ethylene glycol, then pristone and glycerin, right? So these are some of the coolants that are used, or a combination of some of these things, right? Then water is most widely used due to its easy availability and high heat transfer capacity. What's the uh, specific heat capacity of water? Heat capacity.
4.12 joules per kg.
4.2. 4.2 kilojoules per kilogram, right? I don't think it is joules. 4,200 joules, correct?
Yes, sir.
Am I right? So, okay, what is specific heat and what is sensible heat and what is latent heat? What is sensible heat and what is latent heat? Anyone?
Sir, sensible heat is basically in order to raise the temperature. Latent heat is
Yeah.
basically to change the phase.
Yeah?
Sir, sensible heat is about raising the temperature of any particular liquid, sir.
Hmm.
Latent heat is about, changing the phase.
Change of the phase. That's right. So water can absorb quite a bit of the latent heat capacity is high. Even sensible heat also it can absorb quite a bit, right? So that's why water is most commonly used. But there are issues with water because of its corrosive nature and so on. But still, with proper additives and proper surface coatings and so on, you can prevent those things and still utilize the most advantageous features of water. So if you look at pump circulation system, cooling system, it has these five parts basically: water jackets, water pump, Water jackets is like this, water keeps flowing around the cylinder. Then there's water pump, which pumps the water. Then there is a thermostat to ensure that excess water doesn't flow. And then there is radiator, and then there is fan, right? So, so these are the water jackets. I think yesterday I was discussing, you are able to see now around the cylinder. This is piston, and the piston is moving up and down the cylinder. You can see there are gaps within the cylinder block. You're seeing this, right? These slots. So these slots are nothing but slots for the coolant to flow through. Are you guys able to see this? Is it visible for you all?
Yes, sir.
Yes.
Yeah.
Yes, sir.
Yeah, it is through these slots that the coolant flows and takes away the excess heat and prevents them from getting dissipated into the other parts of the um, engine. Then we have water pump. So it's used to circulate the water. Impeller type pump will be mounted in the front end. Usually, uh, we can either have a positive. I think this is a positive displacement pump, if I'm not wrong. What do you mean by a positive displacement pump? What is a positive displacement pump? You don't know what's a positive displacement pump? The output of the pump cannot be zero. That's a positive displacement pump. If you close the valve, if you make the output of the pump as zero, then what will happen? The pump will break. The weakest part will break. If the valve is weak, the valve will break. If the pump is weak, the pump casing will break, whatever, accordingly. Or some of the pipe regions may break. So can you give examples of a positive displacement pump? Gear pump, vane pump, reciprocating pump, piston type reciprocating pumps. So these are positive displacement pumps. I don't know, when they say impeller, you have to check whether it is positive displacement or it's simply centrifugal pump. Like centrifugal pump, it can have zero output as well because it will keep churning the water inside the casing, right? A centrifugal pump will simply keep churning the liquid inside the casing. So we can see the pump is driven by means of engine output shaft only through belts. When it is driven, water will be pumped. Then of course you have a thermostat valve to control the coolant flow to the engine, neither to allow the excess flow and to ensure that there is appropriate amount of flow of fluid to the engine. So that is the use of thermostatic valve. So you can read those details. Then of course we have the radiator. You all know what a radiator does. A radiator is used for cooling the coolant. The coolant flows through the radiator, right? So it flows through the radiator and then there is a fan which sucks the air through the radiator. And when the vehicle is moving forward, the draft, it facilitates the airflow and it makes it easier for the air to be sucked through the radiator grills. So now you can have several types of radiators, serpentine tubes, tubular, cellular type. There can be different types of radiator to enhance that heat exchange between the hot coolant and the air, surrounding atmospheric air. The atmospheric air is used to cool down the coolant, and then the coolant flows back into the um, through the pump into the parts of the engine, right? So that's what a radiator does. And of course, fan, it is driven by the engine output shaft through the same belt that drives the pump. Now you can see all these components are driven by the power from the engine. So when you're having a liquid cooling system, it takes certain excess power from the engine to drive all these components. Whereas in air cooling, as we discussed before, it's not as complex as this. The construction is easier, the cost wise it is low, but it has its own disadvantages and advantages. Here also you have disadvantages and advantages. But usually the liquid cooling system advantages outdo the advantages of an air cooling system, because we want to maintain the temperature of the engine at a certain level, which can be achievable only by a liquid cooling system, particularly for multi-cylinder engine with cylinder blocks and so on, right? So this is a typical engine cooling system. You can see there is a radiator and a fan, and then there is the coolant storage tank, and then there is pump. Then it goes. This is this pipe that you see goes to the engine fluid and then comes back. Then you also have some being used for heater inside the cabin and so on, return hose and fan, right? So this is how a typical cooling system looks like. The engine is not shown here. The engine is connected so that the fluid flows through the engine and comes back, right? So you can see this is a simple line diagram of engine cooling system. So in the exam, you can draw something like this. That's also good enough. You can show the cylinders and then how the fluid goes around the cylinders to carry away the heat. And then it comes from the pump. And then again, after going through the engine components, goes back to uh, it goes back to the radiator. So why is the supply line at the bottom and the exit line at the top? Anybody? Why is the coolant coming from the bottom and going out at the top? Why not the other way? Is there a reason, or we can have it anyway? Yes?
Sir, when the water absorbs the heat, there might be some density variation.
Yeah, Abhilash, what is it? Density?
Sir, when compared to the normal water and the water
Mm.
which absorb the heat, there might be some density variation. Is that the
Mm.
reason, sir?
Yeah, so naturally the hot fluid tends to rise up. It's easier for the pump to operate. It will push the cold fluid below, and because of the heat, hot fluid can easily rise up because of low density and it can flow. So this concept of density difference is used in a thermosiphon system. This is a pressure, you have a pump here, water pump here. So you can also have a thermosiphon cooling system where just by the density difference, the fluid is flowing around the system. So anyway, we will look at it later on. So you see liquid cooling, what are the problems? Air in the cooling system. If there are air pockets, right? If there's air entrainment into the system, then you will not have effective cooling because of presence of air inside the system. Also, the coolant can get frozen. Freezing of the coolant is another problem. And then deposit formation in the cooling system. If there is debris and dirt, because there is an enormous uh, piping and water coolant passages. So these passages can get clogged up because of deposits and dirt. So that is also another problem with liquid cooling. You have to ensure that those passages are always maintained clean and free for the coolant to flow through. So as I said, this is called the thermosiphon system. In thermosiphon system, it's exactly the same system, but the fluid circulates only because of density difference. Since thermosiphon system completely relies on the density difference of the fluid, you need to have a large quantity of the fluid, because if it's a pump, you can ensure the flow of fluid by the work done by the pump. But now, since we are only relying on the density difference for the fluid to flow up and down, so we need to have large quantities of coolant to ensure that there is no dearth or uh, less supply of the coolant. And because of density difference, you should not have any lack of coolant flowing through the system. So it has to be quite bulkier in size compared to a pressure system. So that's another important consideration that we have to ensure. So you can see this is typically a thermosiphon system. A thermosiphon system is not used anymore. Most of the cooling systems use water pumps to pressurize the coolant and make it flow through the different components of the engine. But it has its advantages because it's simple in construction. You can get away with the uh, pump, right? And then it doesn't consume extra power from the engine for circulating the water. Okay, so that is what we have with the cooling system. Now we are moving forward with the lubrication system. So what are some of the functions of a lubricant, right? So you see, the primary function is of course to reduce friction between moving parts, right? We have several moving parts in the engine and it has to minimize the friction between those moving parts. That's the primary function of a lubricant. But there are several other functions. It has to remove the heat generated by friction. So it's not just minimizing the friction, but also because of repeated movement of the parts, a lot of heat is generated. So when so much of heat is generated, you have to remove that heat also. So the lubricant takes care of that. So that's the reason, the lube oil has to be changed after every several thousand kilometers. You see that in trucks and even in two-wheelers, they keep changing the engine oil, right? You're all aware of that. The engine oil has to be changed frequently.
Yes, sir.
Yes.
Yes, sir.
The reason is over a period of time, it gets contaminated because of subject to severe amounts of stress, severe amounts of heat, and you see, it acts as a seal between piston ring and cylinder. I told you, right? The lube oil is actually the final sealant between the piston and the cylinder. So it acts as a fluid sealant. And then it fills the clearance between bearings and rotating. You all know journal bearings, right? What's a journal bearing? What is a bearing, first of all? What's a bearing? Where is a bearing used? Yes?
So when we are connecting the two shafts or when we are transmitting the
Yes.
power,
Yes. So you need bearings to support the shafts, right? Basically, bearings are for supporting the shaft. So where are the main bearings in an engine? To support what? In an engine, what is supported by bearings? Mainly. The main bearings are for supporting what?
sir, shaft.
Come on, it's very simple. It's the crankshaft, right? The crankshaft is supported by several bearings. So we have different types of bearings. One is the roller bearing, another one is a journal bearing. In a journal bearing, what is there in between the bearing and the shaft is nothing but the fluid, right? That's what is present in the journal. You have studied roller bearings and journal bearings, right?
Ongoing.
Now you're studying them, is it?
Yes, sir.
Yes.
It's going on.
Yeah. So in journal bearings, basically there is fluid in between the shaft and the bearing. In roller bearings, there are roller balls, right? So anyway, you will study that. So lubricant is present there in between the rotating shafts and the journal. And also it absorbs the shock and reduces engine noise. Another important. Same as the coolant does, the lubricant also does it. It absorbs several shocks, because it is present between the moving parts. it dampens those vibrations, absorbs those shocks, and reduces the engine noise. Also, it acts as a cleaning agent. It removes abrasive metal worn out due to friction. So, see, with all these functions, slowly the lubricant gets contaminated because it collects dirt, it is subjected to heat, and it is subjected to a lot of pressure and stress. So, obviously, over a period of time, the lubricant starts losing its property, lubricating property. So, it has to be frequently replaced over a certain period of time or after the vehicle has run through certain distance. You have to replace the lubricant. So then, what are some of the properties of the lubricant? So it has to have proper viscosity. That's the most important property. It should be neither too thick nor too thin. So if it is too thick, what will happen? It cannot flow easily to all the engine parts. If it is very thick, for example, grease will only stay in one place. It cannot move to all the parts. Whereas oil can flow. But then if it is too thin, if it is very low viscosity oil, then what will happen? It will not stay in the place. It will just flow down. So you have to have the optimum value of viscosity so that it stays in the place as well as it flows through the necessary gaps to occupy the gaps and lubricate the moving parts, right? So that's called as viscosity index, something called as viscosity index, a measure of viscosity change with temperature. How the viscosity changes with temperature. Obviously, most of the oil, the viscosity. Okay, it's a quiz question for all of you. What happens to viscosity of a gas when you increase the temperature? For liquid, what happens when you increase the temperature? Viscosity
Viscosity decreases.
decreases when you increase the temperature. What happens to a gas when you increase the temperature?
Increases.
Increases.
It increases. It's an important question. You go back and study the reason why. Okay. For gases, usually viscosity increases with temperature. But there is a range and there are some conditions for it. Just look through it, okay? It's an important question. So now, coming back to this topic, how the viscosity of the oil changes with temperature is important for us because the engine and the different components of the engine operate at a certain range of temperatures. They just don't operate at a given temperature, right? So when the vehicle is stationary, when you start the vehicle, it is at a certain temperature, and the vehicle runs for a certain distance, and it is at a certain temperature. And when it's idling and it's running without much of a movement, the engine is running without much of vehicle movement, then it is a certain temperature. So you can know the range, temperature range within which the oil has to function as a lubricant. So it has to retain its viscosity within that temperature range. So single viscosity oil becomes too thick at cold temperature and too thin at higher temperature. So what they do is they add additives to improve the viscosity index so that the oil maintains same viscosity at all temperatures. Because if the viscosity keeps changing with temperature, the essential quality of the lubricant may be lost. So what people do is there are certain additives which are added to ensure that the viscosity doesn't undergo a drastic difference with temperature. So it maintains the viscosity. So those are certain additives added with the lubricant. Then we have something called as the viscosity number. SAE is Society of Automotive Engineers, you all know that. So these numbers, you see W here, 0W, 5W, 10W. W means winter. So these oils which come with the number W are meant for winter season. Okay. And then this 20, 30, 40, etc. are for other than winters because there is no W number here. So higher the number, greater the viscosity. You want high viscosity oil, go for larger number. You want low viscosity oil, go for smaller number. Right? So it's interesting to note that for winters they use low viscosity oil because already with cold temperature the viscosity will be affected. So for higher temperature other than winters they go for slightly higher viscosity because the viscosity will anyway get affected by high temperature. Right? The viscosity may go down. So that's why you can see there is a difference in the numbers also. Then there's something called as multiple viscosity oil, different viscosity at different temperatures, right? So they use a certain low viscosity oil for cold climates, and high viscosity oil for hot climates, depending on. And then there can be a mix up, SAE 5W30. Then accordingly, the oil can handle both the ranges, both the temperature ranges, right? Then the oil or the lubricant should be resistant to carbon formation or oxidation. Because now the more carbon formation happens within the oil, quickly it will lose its property, viscosity property. That's why it should be as resistant as possible to carbon formation and oxidation. And it should prevent corrosion, right? Lube oil should prevent corrosion. It's very, very important property. And also it should resist foaming. What is foaming? Usually when you add water to oil and when you churn water inside oil, have you seen that it forms foam? It forms some froth and foam, right? Have you seen that?
Yes, sir.
Yes. So you see, foaming is caused due to churning action of the crankshaft. It's not just because of the churning action of the crankshaft, but because of presence of certain amount of moisture inside the crankcase. Presence of moisture inside the crankcase. And moisture, when it gets mixed with oil and when there is enormous churning of the crankshaft in the oil, a lot of foam can be formed. So foam reduces the lubrication effectiveness and causes oil to overflow. So that's why additives are added to reduce this foaming, right? Then there is something called as detergent dispersants. It loosens and detaches carbon particles from the engine parts, which is carried away by the oil then. It's like a cleansing action to ensure that the carbon particles are removed from the engine parts. Some detergent dispersants are added. Usually detergent dispersants bring down the surface tension of the fluid, right? Their property is such that the surface tension of the fluid is brought down, also helps in free flow and cleansing of the different parts. And again, the oil should have extreme pressure resistance because engine is subjected to very high pressure in the bearings and valve train. I mean, the oil, as we discussed in the journal bearings, the fluid is subjected to very high pressure, also in the valve trains. So they should be able to resist this oil penetration and be able to resist the decomposition due to high pressures. Then there's something called as energy conserving oil, which improves fuel economy. Energy conserving oil is nothing but it effectively brings down the friction. That's it, right? Then synthetic oil, synthesized from carbon components and alcohol or coal crude oil, it tolerates better heat and produces less sludge. Sludge is nothing but this foaming due to mixture of moisture and oil and then dirt. Together they form what's called as sludge. So synthetic oil, it minimizes the formation of that sludge. So that is the black substance that you will see what is there inside the engine, right? If you leave the engine oil for a long time within the engine without changing it frequently, sludge formation will be there, right? So what are some of the engine parts that require frequent lubrication? Obviously, piston cylinder and piston rings. Main bearings. What are the main bearings? Main bearings are nothing but those bearings which hold the crankshaft. There are several bearings which hold the crankshaft, right? Those are called as main bearings. The large end of the connecting rod, right? Big end and small end of the connecting rod. You see here, big end and small end of the connecting. You all know what's a connecting rod, right? You can visualize the connecting rod.
Yes, sir.
Yeah. What is crank pin and piston pin? What is crank pin and what is piston pin?
Connection between crank and connecting rod.
Yes, the part which comes in contact with the connecting rod. So piston pin is where the connecting rod is connected with the piston, and crank pin is the place where the connecting rod is connected with the crankshaft. So small end and big end. Of course, small end is where the piston pin will come, big end is where the crank pin will come, right? So then you have camshaft, then you have valves. So there are several other parts, but these are the prominent parts that require frequent lubrication. So what are some of the methods of lubrication? So we have mechanical or splash lubrication system, pressure lubrication. Pressure lubrication, we have wet sump and dry sump lubrication, and then there is semi-pressure lubrication system, and then there is something called as petroil system. So this mechanical system or splash lubrication system is a very old system. We don't use it now. So what we may be using now is 2 or 3 mostly pressure lubrication system where a pump is there and the pump circulates the lubricant throughout the engine components. Semi-pressure is a combination of pressure and mechanical. It's not purely mechanical. It's half pressure and half mechanical. So that also may be used in some cases. Petroil system, also known as mist lubrication system. This is obsolete. This is not being used now. But does anyone know what is this petroil system? Can someone guess what is this petroil system? Any guesses? I'm pretty sure you must have seen. Anybody? What is this petroil system? I'll give you a clue. This was found in very old two-wheelers. This lubrication system. Old two-wheelers. Not even in recent two-wheelers.
It is used in two-stroke engines.
A two-stroke engine. What? How is it done? How this?
Lubrication is mixed with petrol.
Exactly. So if you go to the fuel station, fuel pumping station, you must have seen in old two-wheelers, they add a certain amount of engine oil along with the fuel. You have seen that, right? A 50 ml or 100 ml, a certain small
Yes, sir.
quantity of the engine oil, they pour it into the
Yes.
fuel tank along with the fuel. So that is called as petroil system. With petrol, the oil is mixed. So it's also called as mist lubrication. It's not used anymore. This kind of a lubrication system is not used anymore. There are reasons for it. We will discuss that in detail. Okay. Just like to complete very quickly. I'll tell you the gist of all these things. You can read the details. See, when it comes to mechanical system or splash system, it's very simple. You have the engine, right? Engine at the bottom. See, you have the cylinder. There's piston. It's connecting rod, and then there's crankshaft. So below the crankshaft, what is there below the crankshaft? What covers the crankshaft? What is it called as?
Crankcase.
Crankcase. Usually the crankcase acts as oil pan where the engine oil is stored, right? Usually the crankcase, below the crankcase is a deeper uh, tray which holds the lubricating oil. So that's how you pour the oil into the engine, and there is a rod by which you can look at the level of the oil, right? There is a deeper rod, long rod. You pull out that and you can see the level of the engine oil. So now, if you just have that oil pan filled with oil below the crankshaft, you can see there will be a dipper, rod dipper attached to the big end of the connecting rod below the crankshaft. So every time it comes down and goes up, what happens? It splashes the oil around to the different parts of the engine. It splashes the oil around. So that is mechanical or splash lubrication system. The only problem is that it is very hard to lubricate the components which are on the top of the engine, like the valve trains and camshaft and so on, right? So that's the problem in this case. So you can see this is not mechanical or splash lubricant. This is a pressure system. I think the diagram is wrong here. Yeah. So in pressure lubrication system, on the other hand, what we have is it's the same oil which is present inside the crankcase, oil pan at the bottom. So that's why you see the engine is a bit deeper, right? Maybe I have to show you. Is there a way I can draw? Try. I can draw on the screen. Are you guys able to see anything? Is it visible what I'm writing on the screen?
No, sir.
No. Am I still connected?
Yes, sir.
Nobody's responding. Oh, you're responding, but I'm not able to hear probably. Okay. No, any case. So you see, there is a deeper case at the bottom, and there is a pump, submersible pump, which is inserted into the oil. And this pump circulates the oil through the different components. You see, there are holes drilled through. This is the crankshaft. You guys are able to see it. Can someone respond yes?
Sir, the
Yes,
point
sir.
was
Yeah. You're able to see this is the crankshaft, right? So this whole thing is the crankshaft. So you can see holes are drilled through the crankshaft so that the oil can flow through those holes into the bearings and the connecting rod. And then there is a separate oil line which goes to, again, on the top. You see these are the camshafts and the valve trains. To operate those things, you have the separate oil line. So elaborate oil lines are made here to ensure that the oil goes through all the individual components within the engine. And then what happens? This is the return oil return line, and the oil comes back and pours down into the oil pan below the crankshaft. At the bottom of the crankcase, it flows down. So this is called as pressure lubrication system. Even within pressure lubrication system, this is called as wet sump lubrication system. You see it's written here, right? Wet sump lubrication. Because this bottom pan holds the oil. The bottom pan holds the oil. So this is called as the sump. The oil pan at the bottom is called as the sump. Since the sump holds the oil, it is called as wet sump lubrication system. Right? Wet sump lubrication system. So this is the oil storage space, and then this is where from the oil is circulated through the engine. So now the same system, there is a slight modification done that is called as a dry sump system. You see here. In dry sump system, what happens? Let me go back to the previous one. So instead of oil being stored here, the oil is not stored here. Rather, what happens? The oil is stored in a separate reservoir positioned elsewhere within the vehicle. But the return oil, when it comes and pours back here, a separate pump pumps that oil back to that reservoir. And from the reservoir, the oil is pumped to the different components. You see here, this is called as, this is the sump, which is below, this is engine crankcase. Now it's the engine crankshaft is not shown here. So this is the bottom oil pan. So as soon as the return oil flows down here, the scavenging pump pulls that oil and takes it to the supply tank. This supply tank is kept separately away from the engine. And then from this supply tank, the lubricating oil is supplied to the different parts, just like in the previous case. So since the sump is kept dry, there is no oil which is stored within that sump. So this is called as dry sump lubrication system. So why, I mean, there are two pumps used here. One is the scavenging pump, another one is the main oil pump to supply oil to the different parts of the engine. So why should one go for a dry sump system at all? What's the advantage? Why not just a wet sump system? Why you should have a separate tank and then have two pumps, and the pump pulling oil from here and taking it to the supply tank and then again to the different parts? What is the advantage? Yeah. What's the advantage of using a dry sump system?
So we can say, so in case when the lubrication is like reduced, we can have extra lubrication in dry sump.
No, that's not the case. Think about it. Why should one go for dry sump? Why not wet sump? I mean, many of the passenger cars, they use wet sump lubrication system. They don't go for dry sump. Only very expensive cars go for dry sump lubrication system. But why? Why even expensive cars should go for dry sump? Yes? No. Very simple. You guys are not thinking. Think.
Sir,
Why should you go for dry sump system?
in wet sump, there might be evaporation of the oils due to the heat.
Due to the heat. Okay. Yeah. But it cannot escape anywhere, right? It's going to be within the casing anyway. Now imagine when you have a wet sump system, the oil is stored in the sump below the engine. So obviously you have to keep the oil pan quite deep, correct? The oil has to be stored below the crankcase, correct? So the engine height will become quite, the engine will become quite deep. So you can't position the engine lower, because if you position the engine lower, the oil pan comes down below, which is not safe. So you have to position the engine slightly higher up. But whereas in a dry sump system, you are getting away with that bottom oil pan, correct? When you're getting away with the bottom oil pan, the dry sump can be a very shallow one, because as soon as the oil comes, it is scavenged to the separate reservoir. So obviously you don't have a deep oil pan below the crankcase. So what can you do? You can lower the engine. The height of the engine can be lowered. What's the advantage of lowering the height of the engine?
Center of gravity.
Center of gravity goes down, you get better stability, right? When the center of gravity goes down, you get better stability of the vehicle. There's another advantage. Now, the orientation you see in this wet sump, since it's a submersible pump, the orientation of the engine can sometimes leave the pump exposed without any oil. Let's say the engine moves one side. Because of the movement, all the oil can come and get stored up in one side or the other side. The oil can keep moving within the reservoir. So because of which the pump sometimes may be submerged within the oil, sometimes may not be submerged, right? The orientation effects will have some issues. But then here, orientation is not an issue because it's in a separate reservoir. The orientation doesn't become an issue at all for this, right? And then you have a flexibility of positioning the reservoir anywhere you want within the vehicle. And then there is another important advantage. Now the crankshaft, when it is rotating, in a wet sump lubrication system, sometimes the oil tends to get around the crankshaft as it is rotating because it is just below the crankshaft. See, when you try to move your hand within fluid, you experience greater resistance, right?
Yes,
You
sir.
move your hand in air, you don't experience so much resistance. But try moving your hand inside water, you have extra resistance. Same way, when the crankshaft is rotating freely, it experiences lesser resistance. But when the lubricating oil gets around the crankshaft, which is possible in a wet sump lubrication system, what happens? The crankshaft experiences a certain resistance, because of which the power output the power output can be jeopardized. Whereas in a dry sump lubrication system, the oil never gets around the crankshaft because it is kept separately. So this advantage enables the crankshaft to run with least resistance, and you get quite uh, uh, quite a bit of increase in power output. That's why expensive cars, they use dry sump lubrication system and they have better power output. So these are some advantages of a dry sump lubrication system over a wet sump. See, both are pressure lubrication systems when you go for an automobile. But there's a difference in the way in which the oil is supplied to the engine parts. So you can read through the advantages and disadvantages. Only disadvantage is that increased weight and complexity because you have additional parts here. So semi-pressure is nothing but the combination of a splash and pressure lubrication system. Petrol system, as I said, you pour the lubricating oil into the fuel tank along with the fuel. So the advantage is that you don't require a separate lubricating system. There's no maintenance cost and the weight is reduced because you don't have separate uh, components for this system. But disadvantage is that if the oil is less, there is a chance of engine seizure. But if you add more oil, then excess smoke will come because it kind of pollutes the fuel. The fuel is not pure anymore. You're adding oil with the fuel, right? So that's why people have started avoiding it. It's almost obsolete. Nobody uses a petrol system anymore for lubricating the engine, even in two-wheelers. They only use semi-pressure or pressure lubrication system. All right. Okay, so there are other components like oil filters and oil pump and oil cooler. And then there is a short write-up on sludge. You can see this is what sludge is all about. It's a combination of oil with moisture within the crankcase and along with dirt, right? So usually desludging has to be done. Frequent cleaning of the engine parts has to be done. Otherwise, it can be quite corrosive and it can affect the efficiency also. So that's about it for cooling and lubrication system. Any questions from you guys? Guys have any questions? I mean, those who have questions can stay back and ask questions. If you don't have any questions, thank you. You can leave. Thank you very much. And tomorrow, be prepared for the exam. The exam will be at 12. What will be the portions? We will have it till what we discussed today. Yeah. The portion is till what we discussed in this class. Okay. That will be the portion. I'll upload this class also and the PPT as well in LMS right now after a few minutes. Any questions?